Welcome to the ICND 1 demo lab. As we can see here, I've got a Visio diagram of all the different things we're going to be playing with here. The workstation that I'm on right now, that's running Visio, connected to a Cisco workgroup switch. It's a 2950 series switch, connected to a 2800 series router that's running firewall software because, as we all know, we don't connect directly to the internet without a firewall in between. So we have the firewall services running on the router, and I'll be showing you how to do that at some point in time. Off to the interweb, and I put a link over here to Google so we can play with some HTTP stuff during our lab. I also have a shortcut link here for our Wireshark application we're going to use for sniffing purposes to watch traffic as it goes by. Now, Wireshark used to be named ethereal, so if you see things that reference ethereal or ethereal out there, realize that due to trademark disputes or whatever dispute they had, the guys who wrote ethereal had to change their name. They decided on Wireshark, and there we have it. So that's what our sniffer is going to look like that we'll be playing with in this particular lab here. All right, so the first thing I want to do is I want to bring my workstation up. And as we can see down here that we currently don't have connectivity because we don't have an IP address. So I want to go through the process of taking a look at, I'm going to full screen my Visio document here. I want to take a look at the process that it takes to actually pull an IP address from a machine here. So we're going to go ahead and open up a command window here. And there's a lot of little tricks that I pulled to make this Visio diagram do what it's doing here. Me simply clicking on an icon in Visio to bring up a command prompt is it's actually a pretty slick thing. But at some point in time, I'm sure I'll show you guys how to do that. All right, so sitting here from a command window here, if I type in ipconfig from here, which is the command in Windows we use to discover what IP addresses are running on a machine, we can see that currently we don't have an address. Now, the command to solve this would be ipconfig/renew. And of course, if you're running Vista, these commands don't work anymore because Microsoft didn't want you to do this from command line, which is one of the reasons why, since I want to do some control mechanisms here, I'm using Windows XP to control these things a little bit simpler in a lab environment than I could with the wizard type things that we get in Vista. So, okay, so I'm going to, before I hit enter there, I'm going to start my Wireshark application here. Starting this, gives me a little warning about opening things like that. All right, so starting this is going to capture the packets live as they occur on the network, and specifically want to watch this DHCP relationship here. So I'm going to start a new capture, and then I'm going to go back here, and then I'm going to hit enter to actually pull those. You can see in the background we're starting to get some stuff going by, and there's our address. Okay, so let's head back over here and go ahead and stop this capture and take a look at the stuff that we got to see. Of course, there's quite a few interesting things that happened during this process. Now, these three windows, this window is showing you all the different packets. As of right now, there was 23 packets in that time frame. This is the actual packet. We can break it down and look at it from a Ethernet layer 2 perspective, or layer 3, maybe even layer 4 perspective. And down here shows you the raw information broken out into hexadecimal. So let's go back up here to packet 1 here. Packet 1 was a loop packet. That's an Ethernet test packet. We'll see quite a few of those. Matter of fact, I can sort by protocol, and I probably should see a couple loops. I can remove that stuff with filters and other things in within Wireshark, but I won't at this point. All right, so the next thing we saw was a DHCP discovery transaction. So we sent out a DHCP request. Right? The DHCP request went out, and we'll break this down from a layer 2 moving up here. So layer 2, we saw, information about the frame going out. The protocol was Ethernet IP UDP boot P. So it's a Ethernet packet, a IP header, UDP header, and then a bootstrap protocol, which is, I did mention that we were talking about DHCP, was the precursor to DHCP, the bootstrap protocol. The Ethernet header itself, notice that the destination was all F, so it was a broadcast there. The source address was our micro STEE, that's the manufacturer of the motherboard, as organizational unique identifier that Wireshark recognized, which is actually registered 0013D3, and then the actual MAC address serial number, if you will, for this machine, CE2933E. So that went out. It's protocols IP, so notice the type field here, 0x800. We'll close the Ethernet header. Look at the IP header. Source protocol is all zeros because we don't have an address yet. Destination was a broadcast address. So I can look a little farther into that. The version was version 4. It's a 20-byte header. Diffserv wasn't set. Now, diffserv, that's part of the TOS bit fields, type of service fields. So this is to do quality of service, so we don't have any QoS set for our DHCP, which wouldn't be normal. Flags, fragmentation, offset, I wouldn't imagine we'd be fragmenting it. Protocol was UDP, OX11. Now, 11 converted to decimal would be 17. All right, and then a header checksum to make sure that the header didn't get modified, source and destination IP addresses. So if you go back and go look at the IP header diagram that you had, you can see that this formats exactly out to that IP header diagram that we saw in the slide presentation.